We learn about the metrics for text summarization, and as I mentioned, there are three kind of metrics. The first is BLEU, the other is rough and method. We learn about BLEU, blue. We learn about rough, and today we are going to learn the next section, which is about method. For the meteor, we call meteor. It stands for metric for evaluation of translation with explicit ordering. So they put the short as meteor. In this metric, it incorporates recall, precision, and additional semantic matching based on stems and paraphrasing. So we call stems. If you still remember stemming. Stemming means we are going to make the word into the original word. Let's say we have learn with T. Then we are going to find the original. We want to find the original verb, which is learn without T. Then we want to check the recall, the precision, and there are other semantic for stems and paraphrasing. So paraphrasing means we are going to look at the other alternative of words. For example, if I really love to study programming. So we can do some kind of paraphrasing. For example, programming is a field that I love. So this is paraphrasing. The meaning is the same, but the structure of the words will be different. Yeah. Now let's see with the meteor, we can have again the reference and the generated. Reference means we have a label or we have a kind of sentence as the true or the actual label, and the generated is the predicted or the summary from the text. Okay. We have the cat is sitting on the mat, so we can create the token. The cat is sitting on the mat. And the generated for the text summarization, we can get a cat sits on the mat. Oh, sorry, a cat sits on mat. A cat sits on mat. So using this method, we can calculate the precision. So yesterday we learned how to calculate the precision. Now we can look at the precision for the unigram. For unigram means we use only one word. We want to see the number of intersection divided by the total unigrams in the generated summary. Now, if you look at this one, this is not match. This one match. This one not match. This one not match. This one match. This one not match. And this one match. So we have 1, 2, and 3. So there are 3 that intersect. And the total of unigrams in the generated summary, we have 1, 2, 3, 4, 5. Then there are 3 tokens that are available in the reference among 5 tokens in the generated summary, then we call the precision is 60% or 0.6. The recall, we want to see the number of intersection divided by the total unigrams of the reference summary. In the reference, we have 1, 2, 3, 4, 5, 6, 7. It means 3 intersect words among 7 words in the reference. Then the recall is 0.43. 43% from the words are available in the reference. 60% of the word in the generated summary is available in the reference. Now we are going to look at the F1. The F1 means we need to calculate the precision and recall multiplied by 2 divided by precision plus recall. We have the precision, we have the recall. You just put the value here, and then we got the F1 is 0.5. In order to calculate the meteor, we have a word penalty. So the penalty means something that you can see if the word is not contiguous, okay, contiguous or continuous. We need to compute the fragmentation penalty. We need to count the contiguous or the continuous matching segment. So in this example, we have cat. Okay. We have cat. This is a single word. These two are matching. Okay. They are matched. The reference and the generated summary, they have cat. We call this is the segment 1. We call this is segment 1 because there is no other word before cat and there is no other word after cat which is in the match. So we need to find another segment. In this case, we are going to check the segment number 2. What is segment number 2? So after is, sit, yeah, sitting, nothing. So we can find on. Okay, on, they are matching. And because these two words are matching, now we want to check this word after on, it is met. Even though we have this text on the mat, okay, but we can see these two actually they are contiguous, or this one is continuous. Then this is regarded as two contiguous words, or this is the two continuous words on mat. So after we have cat, the next segment is on mat. Okay. So you can check again later if there are other kind of matching words and whether they are contiguous. We need to calculate how many segments do you have. In this case, we have 2 segments. The first segment is cat and the next segment is unmet. Then we can calculate the penalty. How to calculate the penalty? P is the penalty. It is the number of segments. In this case, there are 2 segments. And it is divided by the number of matches. So we have 1, 2, 3. So there are 3 are matched and only two segments are available. And then we calculate with half or 0.5. It is to make sure that if we have 2.3, then this is 0.6. If it is too high, then it will cause the meteor score will be very, very small. So the penalty should be reasonable. That's why we will multiply with some reasonable value. In some cases, yeah, you can put a big value, but usually we just put 0.5. Let's make it as half. So the meteor score will be the multiplication of the F1. F1 is the 0.5. And then we will calculate, we will multiply with 1 minus the P, 1 minus the penalty. So if we have this penalty, if you have the penalty is very high, it means 1 minus 0.6. So this will be very low. If this one is very low, then the meteor score will be very low, and this make the penalty is a kind of big penalty and lower the meteor score. That's why we will do some kind of weighting with 0.5. So the M1 score multiplied by the 1 minus P, F1 score is 0.5. This was from the previous calculation. Okay, F1 score from this one. And then we multiply with 1 minus penalty. The penalty is 0.33. Then we get the value 0.5 multiplied by 0.6. It is approximately 0.33. So what does it mean by this one? So it is because the meteor score reflects that the summary how similar with the reference. This one, if it is high, then it shows high similarity. The high similarity means we want to check if it is very good on the matching. So if those match a lot, then yes, we can get this value very high. If this match is small, of course, this value will be very low. If you look at this one, there are 7, okay, and this one there are 5, and only 3 match. And among those 3 match, we have 2 kind of segments. That's why the value of the meteor score is a little bit lower. It is because of the difference in length. The length of this one is 7. The length of this one is 5. The difference in length is naturally reflected in the precision and recall calculation. So you can see if it is different in the length, let's say this one is 5 and this one is 7, then the value of precision and recall will be lower. Okay, let's take a look on the Google Colab. For this section, we need to install a library, evaluate. And after you download the library, we can use the library, evaluate, and we use the metric. In this case, we are using BLEU, blue. Now I have two lists. The first list is prediction and the other is reference. The prediction means the generated summary. This is the summary. So let's say this is the summary from the algorithm. Okay. The summary of this one, we got two text. Let's say this is the text, hello there, General Kenobi. And the other text is long time no see. The reference, we have three. Okay. Hello there, General Kenobi. Hello there, and long time no see. Then you can calculate the PLEU score. The PLEU score is the comparison between prediction and reference. So we can print the result. Yeah, it takes some time because they are using another library and the library is, I think, not that efficient. In the library, we need to have a script and they need to build some extra modules. That's why it takes some time. We can see here the blue score is 1. If you learn from yesterday's lecture, we know that the blue score, if it is high, it is high similar with the reference. If you look at the precision, so precision we have 1, 1, 1, 1. The precision here, it is for the n-gram. This is for the n equals to 1 or unigram. This is for the bigram. This is for the trigram. And this is for n equals to 4. If you look at this penalty, the brevity penalty, so we learned about the BP yesterday. So the BP is 1. And the length ratio, because some of the texts have different length, so there are also another metric about the length ratio. The PLEU usually is used for the translation, but we can use for the summarization. The translation length is 8 and the reference length is 7. So we can get from this. The translation, it means this one, there are 8. And in this case, there are the reference length, there are 7. Yeah. Now let's see with the text from the PowerPoint. We have the prediction, which is the cat set on the map. And the reference is the cat is on the map. Let's use the PLU to compare the prediction and the reference. Okay, the PLU is 0. Okay. It is because we are doing the precision for all the grams. This is n gram equals when n equals to 1. This is n equals to 2. This is n equals to 3. And this one is n equals to 4. Because of this one 0, that's why it is 0. Okay. If you look at the calculation that I show you before, this one yesterday. So if you look at this PowerPoint, I just give the calculation for the unigram and the bigram. Okay. If you use the trigram and n equals to 4, the result will be 0 because we have 0. So we can limit the PLEU, and the penalty is 1, the length ratio is 1 because the length is the same, and we have the translation length is 6 and the reference length is 6. So this is the explanation. The PLEU is the overall BLU score, and the precision, it is a list of precision score for the n-grams. We have 1 gram, 5 gram, 3 gram, and 4 gram. If all precision is 1, then it means that all n-grams in the prediction were found in the reference. This is the brevity penalty. So we got the BP. Okay. This is the BP that we calculate. This is the brevity penalty. The length ratio is only to measure the ratio between the reference and the generated text. This is the translation length and the reference length. The other metric is rough. We can also calculate rough because it is in the separate library. The idea is the same. We need to have the prediction and we need to have the reference. We just need to call the function. In this case, we are using rough. We use rough and then compute between the prediction and the reference. The matrix is somehow a little bit different because we are using rough 1 means this is for unigram, rough 2 it is for the bigram, rough L you try to find the longest common subsequence. This is rough L sum. We use the log to measure this one. Yeah, we have only 4 on this one. On the PowerPoint, I mentioned that there are N, L, W, and S. S is the skip bigram. So in this case, they have also another kind of measure, which is the rough L sum. Yeah, you can look at the result from the PowerPoint. We use the cat set on the mat. The cat is on the mat. And yeah, this is the rough 1. This is the rough 2, rough L, and the rough L sum. For the meteor, we need to install another kind of library. And okay. It takes some time for the installation, and we need to install another kind of library to run the meteor. So the first library is the dataset, okay, and the other library is Comet. I think the author is very interesting on the planet. That's why they use meteor, they use Comet for the name. It takes some time for downloading all the libraries. Last time I tried, it took like 1 minute. Let's see, another 30 seconds. Yeah, in order to run this kind of metrics, we need to rely on other libraries. And of course, this kind of libraries need some space in your computer. For example, in this library, you also need to download the Hugging Face. So they are connecting to the Hugging Face, and then they are also connecting to some of the deep learning libraries like transformers, and they are also connecting to the GPU, because if you are doing the analysis with GPU, the metric should run in the GPU. Okay, it is more than 1 minute. Mhm. Yeah, whenever I run in different environment, I need to install again. Okay, so when you run this one in your computer, of course you need to install again in your environment. It took a lot of time. Okay, I will get back later after this finish. Why it takes more time than I expected. Okay, then let me just continue first. Okay. So after the Google Colab, we can understand some of the algorithm, how to calculate, how to generate the text summary. So let's look at some of the basic algorithm for text summarization. In the first section, I would like to explain about the extractive text summarization. It extracts text based on vectors such as what are the texts to be summarized. The other kind of things, we need to find the most essential sentences. We say top K. It means we can define the K. If the K is 5, it means I'm going to select the top 5 sentences. Let's say we have 100 sentences. Okay, we have 100 sentences. Then I will select only the top 5. That's the meaning by top K. The importance of each of these phrases to the overall check. We need to check whether the phrase, it means subsection of the sentences. Maybe we have the word artificial intelligence. So if the word appears in the sentence, then okay, we can say that this sentence is important. Or if you have another kind of phrase, let's say Internet of Things, then if the sentence contains the word Internet of Things, it is important. Okay. So those kind of things we need to check based on the text or the sentence with the particular keywords. Now let's see with one of the algorithm. You already know the TF-IDF. We have 3 sentences, 1, 2, 3, and the sentence 1, artificial intelligence is transforming industries. The sentence 2, AI is an important field of research, and the sentence 3, AI has application in healthcare, finance, and many other areas. Let me just remove the stop words. If we remove the stop words, it means we remove is, an, of, okay, has, in, an, many, other. Okay, so we remove those. Then the remaining words will be the artificial intelligence transforming industries. For the sentence 2, we have AI, important field research. In sentence 3, AI, applications, healthcare, finance, and areas. Now, we want to do the TF-IDF. Okay, I think you are already expert on calculating the TF-IDF. We have the TF1, TF2, TF3. The TF1 means the term frequency for the sentence 1. The TF2 is the term frequency of the sentence 2. And the TF3 is the term frequency on the sentence 3. The DF means whether the words are available on the 3 sentences or not. So this is the TF for each word. And we can calculate the TF IDF1, TF IDF2, we have the TF IDF3. So this TF IDF1, it means this is the result from TF1 multiplied by TF. This one is the result from the TF1 multiplied by TF, and so on. For the TF IDF summarization, it is easy. We need to calculate the summation. So we do the summation. The first word plus the second word plus the third word plus the fourth word. And we got the summation 0.4772. For the TF IDF2, yeah, we also do the summation and we get the value 0.4. And for the TF IDF3, we also do the summation. And we do the comparison. The highest scoring sentence is sentence 1. Why? This is the highest. Because based on the summation, the value is 0.47. This is the highest among the other sentence. Because this is the highest among the other sentence, then we can say the summary. Let's use sentence 1. Then among the 3 sentences, the summary is the sentence 1, and the summary is artificial intelligence is transforming industry. Okay. And this is the summary. The other kind of algorithm, we want to use the text rank algorithm. This algorithm is based on the page rank algorithm. Before I continue this, John, let's see the Google Colab. We must restart the runtime in order to use. Okay. Let me check if I run this NLTK and then if I again using the evaluate, let me call the method. So I'm using the prediction and the reference. Yeah, for the first extraction, it takes some time. Okay, we can get the method value 0.69. Okay. The prediction is this one, and the reference is this one. So you can try later with this matrix meteor, and you can use the text from the PowerPoint, whether they are the same. Okay, let me get back to this text rank algorithm. The text rank algorithm is based on the page rank algorithm. The page rank is used primarily for ranking the web pages in online search result. Now let's look at the detail on the page rank. We call it page rank or PR. PR page. So PRA, it is the page rank of page A. Let's say A is a web page. And we are going to use the formula like this one. 1 minus D divided by N plus D multiplied by the summation of the PRI divided by LI, where I is in the in A. Maybe it is too complicated for you to understand. Let me make it simple like this one. D. Okay, what is D? D is the damping factor. Damping. Do you know what is damping? We have the damping factor, and typically is 0.85. We call it damping factor. It means whenever you do the Google search, what will you see in Google? Okay, like what I showed you yesterday. When was the World War II end? So when you ask the Google like this one, when was the World War II end? We can get like the Wikipedia or the National Museum, or this is another encyclopedia. Okay. Now the question is, which one will you choose? Are you going to choose the first, or are you going to choose the second, or are you going to choose the third? We are not sure. Okay. But Google show this one as the first. Okay. So this is always the first. Whenever maybe you make almost similar sentence in this Google query, you will see almost, yeah, maybe in most of the time, this will be in the number one. Now, we need to put the damping factor. It is to avoid the page rank. It is always in the number one, because people may not choose number one. Why? Because some of them might be sponsored. You know the sponsor? Let's say I want to see about the cloud server. In Google, you can see here the sponsor result. What is sponsor result? It means this company pay to the Google. And once they pay Google, you can get this one at the first. You can get this one at the second. Okay? You can get this one at the third. So those are the sponsor. Because they pay to Google, they appear in the first part. For me, sometimes I do not want to choose this one. Because once you click this one, it means they will get more money. Okay. So I will choose the below part. So I will not choose the first one. I will not choose the second one, but I will choose the algorithm that Google gave. In that case, it will not always the first page. So you need to give the damping factor. It is 0.85. It means whenever you have the rank, it will not always be in the first part. There will be always the possibility that people do not choose the first section. There is a possibility that the person or the user will not choose maybe the second one. So what is the probability? They claim that you can choose 0.85. That's why we choose the 0.85 for the damping factor. So there is a probability that the person will not choose the result at the first sight. N is the number of pages. So let's say, for this example, I will use 4. In So how many pages, a set of pages linking to the page A? And L is the number of outgoing links from the page I. So we are going to look at what is the outgoing and what is the in from the page I. Now let's suppose we have 4 pages. We have W1, W2, W3, and W4. These pages contain links pointing to each other. Some pages might have no link. We call this is dangling pages. Dangling pages means there is no link. Now, let's see this one. We have W1. This is the web page 1. There is a link to web page 4 and web page 2. So maybe if you look at the neighbor, okay, maybe the neighbor links to maybe Jungang Ilmu. Neighbors link to maybe KBS News. So because they have a link to this web and this web, we can say that the W1 there are 2 outgoing links to W2 and W4. Then the outgoing is 2. W2 there are 2 links. So W2 it can go to W1 and it can go to W3. Then the outgoing is 2. W3. In W3 there is no link. Some pages might have no link. We call it this is dangling pages. Okay? Because there is no link, we call this is dangling page. And W4, we have 1 link to W1, then the outgoing is 1. The web page W1 has links directing to W2 and 4. W2 has link W3 and W1. W4 has link only for W1 and W3 has no links. Hence, it will be called as dangling page. In the page rank, okay, dangling nodes or nodes with no outgoing links are typically handled by redistributing their page rank equally to all nodes in the network. Redistributing. It means if I have no outgoing, so we assume that we can go from W3 to W2. We can go to W3 to W1. We can go to from W3 to W4. This is assumption. It is to avoid 0. Okay? Because if the outgoing is 0, then we need to put a big value. We need to put something like the maximum value. And the maximum value is the total of all nodes. So as if they link to every page. So this is done to prevent them for trapping page rank. So trap means we are not linking always to W3. From W1, it will go always to W3. From W2, we can go always to W3. So this is trap. So in order to avoid this trap, then we put some big value for this dangling page. So let's assume the damping factor is 0.85. So the initial page has the equal page rank, which is 0.25. And because we have 4 pages, so we can do the calculation. The initial, that be the initial probability for web 1, web 2, web 3 and web port, each of them will be 0.25, 0.25, 0.25. Then we can do just putting all the values. 1 minus d divided by 4 plus d multiplied by the probability of W2, probability of W4 divided by the outgoing and divided by the outgoing. What is the outgoing of W2? The outgoing of W2, there are 2. So we divide with 2. What is the outgoing of W4? We have 1. Then we put 1. Then you can just calculate. This is the result from this. 1 minus 0.85 divided by 4, it is 0.0375. And then D is 0.85 multiplied by 0.25 divided by 2, 0.25 divided by 1. We can get this value. So this is the page rank of Web 1. Okay, let me stop here. Let's have a break. So I will continue after the break.